Yes.
Here we go.
No sound.
Okay, coming. All right. So I need to get out of that.
Yeah, unshare.
Share. Come on. Stop share. Okay. Share screen.
Lower left, share.
Yeah.
Audio.
Come on. And share. Let's try it again.
I say only, it can cause
Perfect.
very serious damage. All right, what's up, everybody? You're watching Bob's Decline, lineman blogger. For those of you that are new to the channel, my name's Aaron. I've been a lineman on the East Coast of Canada for about 18 years now. Today, I wanted to go over an incident that happened at my workplace, at our workplace, that involved a piece of equipment making contact with low voltage, 120 volts. The reason I wanted to share this with you all is to show, even though it's only 120 volts, how much power is actually behind electricity in the right circumstances. We're gonna have to make this one quick. I mentioned in my last video that I had some stuff going on in my personal life. So everything is done deal now. My family and I bought a new home. So we're super excited, but we actually had a huge storm roll in during the move. So we pretty much threw all the boxes in the garage. Nothing's unpacked. We're sleeping on mattresses on the floor right now. So if the wife catches me editing this tonight and not putting our beds together, it might not go so good. So we're gonna make this quick, guys. The reason, again, I wanted to show you this is to show that even though it's only 120 volts, it can be very serious. It can still be lethal at that voltage. When you hear this saying, it's not the voltage that kills, it's the amperage. I hate hearing that from people. It can be extremely misleading. In this particular case right here, you'll see there's actually no amperage on this line. This is 120, 240 volt triplex. The meter's pulled off. If you were to put a voltmeter across, you'll see something like 122, 124 volts phase to ground, and the amperage is going to be 0. We have 2 live leads coming down into those 2 lugs. We got 120 volts in this guy, 120 volts in this guy. So right now the power in the building is still off. Once we put the meter on, it's going to bridge the gap between these 2 guys. Power is going to flow out of here, through the meter, into this guy and into their panel. Now that doesn't mean that this is safe in any way, shape, or form. If I were to say, grab a hold of one of those live phases with my right hand, grab a hold of that neutral with the left, I'm going to complete that circuit. There's going to be a path, and then you will see that amperage. It's almost like if you turn on your garden hose, there's water in the hose, but it's not flowing. The amperage is the flow. So as soon as you squeeze that trigger, that water starts flowing, there's your amperage. Same thing with the power lines. It might not be feeding anything, but if you make contact with it, that's when you complete the circuit. That's when you squeeze the trigger of that hose. That's going to create the flow. The line coming out of the transformer to your home, that 120 volts, it doesn't sound like much. It's not fused. If there's a dead short, you've got to rely on the fuse on the primary side in that cutout to blow. And it takes quite a beating before it'll actually blow. So if you make contact, let's say with your body on a secondary side between a phase and a neutral, that's not going to draw anywhere near enough amperage to blow that fuse. But there is going to be enough amperage that can cause serious injury. So I don't want to get into any procedural steps. I wasn't there when this happened. The lineman that was involved, a very good lineman. I would work with him any day of the week. In fact, I do work with him quite a bit. He's a very, very well-trained, experienced lineman. Great guy, was following all his steps, had all of his PPE on. Unfortunately, there was an accident. There was no injuries. Safety glasses were worn, which is one of the most important pieces of PPE when there's an arc flash, is your safety glasses, and all of his FR clothing. Wintertime helps when you got the big coat and stuff on. But the item in question was actually an impact gun. So a lot of times it's super normal to work on secondary while it's live. You could be tightening up a dead end unit using an impact gun, and that neutral, basically those bolts you're hooked onto are part of the neutral wire. So if another metal part of your gun hits a phase, or if there's a crack in the insulation or a bare phase, that's going to create a path through the drill. So this is solid steel, and you can see right here, that blew a hole through solid steel. Now that's only 120 volts. We're not talking 7,000, 69,000. That's 120 volts come in through here and out through the side of that steel collar, and it blew a hole right through the steel. Now, not only did it blow a hole through that steel, but as the current was traveling through the socket, there's a removable, whatchamacallit there, chuck, whatever. Anyways, as the current passed through that socket, it actually welded the socket onto the removable adapter. And this collar no longer moves at all. It also completely melted that steel. So the drill still works. She's a little lopsided, but that's 120 volts, guys. I can only imagine the sparks that were flying off this thing. Even a piece of that steel, that's going to be liquid metal. If a piece of that lands on your neck, your face, anything at all, that can cause some very serious burns. Even the head, it warped the shape of the head. And I know I've said this 10 times in this video, but that's 120 volts. So for those of you that are watching that aren't linemen, anytime you're working on stuff in your house, you get your 120 volts, you may have had an incident and the breaker popped. It's not very dramatic. And then you go out in the field during a storm and you see some lines coming off a street light and you say, oh, geez, that's only 120 volts. I work on that all the time. I'm just going to kick it off the road, whatever. It still can be very serious stuff. That 120 volts can cause a lot of damage. When that fuse doesn't pop, it just keeps pumping out that current. It will burn, as you've seen, through solid steel quite effortlessly. I'm sure there's lots of you linemen out there that have seen pairs of bolt cutters. When someone grabbed all 3 wires and triplex and tried to give that a snip, it pretty much disintegrates a hole into your set of bolt cutters the size of the wire. It doesn't take much, and to see it in person, it's extremely violent. There's a lot of heat, a lot of sparks flying at your face. You got to take this stuff serious. So I know, guys, a lot of times we get pretty involved in the comment section discussing procedures and kind of what went on in a video. And like I said, I wasn't there when this incident happened. I don't really want to discuss the incident in the comments. What is important to know is that nobody was hurt. All PPE was worn, and an incident like this we can all use as a learning experience, as a reminder that even though it's only 120 volts, I say only, it can cause very serious damage. That's solid steel, so you can imagine what kind of heat was involved to melt that and what it can do to the skin on your body, or if ever a piece of that landed on your face, that hot metal hit you in the eyeball or in the face or something, it can cause some very, very serious damage. So that's it for today, guys. I'm going to try to get this one whipped up tonight there. I got all kinds of unpacking to do at the house. It's a nightmare, but we're excited. Everything is good on this end. Oh, and we got a new product that might be coming. This thing's going to be a game changer for our trade, for Working Storm. So I'm not going to tell you guys what it is yet. Still kind of working on a few things. We're hoping to cover this in a video, maybe even within the next few weeks. So if you're not subscribed, consider doing so.
Okay, guys, we won't get into that, whatever he's talking about, but anyway, just to emphasize just what he was emphasizing about 120 volts, it's still 120 volts. It only takes a 1/10 of an amp to get your heart out of rhythm, to really to kill you. What he said there was very true. About your PPE, you should always wear your rubber gloves, safety glasses. That's a prime example. of safety glasses and hard hat when you need those the most in your gloves. I guess the guy that was tightening down with that impact wrench didn't realize he was gonna cause a short or get into something. And that's most of the time when you really don't expect things like that to happen when it happens. So always be prepared. Couple things. You want to look out. I'm gonna back this video up a little bit. That's where was he at? No, he's working on an energized transformer here. He's got on leather gloves. Looks like, is that what it looks like you, Professor Shoemaker?
There's actually rubbers underneath those. I think.
Is that low voltage gloves?
I don't know 100%. Looked like he had long cuffs on him. Just go ahead and hit play from there.
Do it now?
Hit play from there.
I'm going to complete that circuit. There's going to be a path, and
Yeah, I
then
see it.
Yeah, you see the cuff.
Yeah, those must be low voltage gloves. But there's some situations when you get out there just like this.
she had a huge storm roll in during the move.
All right, you saw the end of the neutral on the triplex, and you got the two hot legs pulled banjo tight. This is a situation you really want to de-energize this as soon as you get to this situation here, because that neutral balances out those two hot legs, and of course that could cause 240 volts on one leg and 0 volts on the other leg going into customer's home. And that could potentially cause a fire. And you do not want to pull this back up. You don't want to be completing that path, grabbing it here and then grabbing the other end of it here to put it back together. Those kinds of things, very dangerous. But 120 volts, it will hurt you. It can get you. Just like working on primary, you want to test your PPE before you wear it, especially your rubber gloves, and make sure you do wear your safety glasses as he stated. Professor Shoemaker, you got anything?
Yeah, it's surprising, gentlemen, when you look at the reports and safety reports from industry, as far as electrical hazard that you're working with out there, about 30% of the electrical, injuries and whatnot are electrocution, and 70% of those are arc flash. So something happens, and an arc flash occurs. We saw some arcs yesterday that really were just load arcs, static charge arcs and load arcs. But if you have a phase-to-phase or phase-to-ground arc, which it sounded like by his tool, that was a phase-to-ground arc?
Yeah.
Yeah, they're really intense, and you're going to have flying molten metal and really high heat, and you're close in proximity to something like that. That's
another
gonna be-
metal part of your gun.
Go ahead. I'm sorry.
Yeah. So you'll see some linemen out there that insulate their own tools. Don't trust in that. They put tape around them and rubber covers and everything like that. If you have to, and that's pretty much what he said here. You can work on 120, 240 with your rubber gloves. Don't think it's any less hazardous than 7,200, 1,900, whatever. You still got to maintain those distances. And I've seen plenty of electricians, and man, this upsets me a good bit, that will walk up to a meter base and see something going on in a meter base, and I'm going to stick my screwdriver in there, or a wrench or anything like that. If you need to work 120, 240 in a small space, de-energize it. All right, just a slip of the tool or anything like that, you're going to have a massive explosion that's going to be right there in your face. So you're only de-energizing one customer, and typically the meter's out anyway if you got to work in there.
Right.
Go ahead and kill the secondary side of that meter base also. But arc flash, we talk about it a good bit, is the majority of electrical injuries that you're going to see out there in the industry. And me, I love to chew videos up. Play a little bit more.
Hits a phase, or if there's a crack in the insulation,
stop there.
That's gonna.
All right. Wear a t-shirt that fits, 100% cotton, and get that jewelry off your body.
Yeah.
Okay. Even if that thing is covered up with fire retardant clothing, say that hoodie and that vest and that t-shirt, heat that extreme from an arc, that metal's going to attract it, and they're going to be surgically removing that from his neck. Okay, even if it's covered up with your clothing. So you guys get rid of that jewelry. This guy's talking safety, 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 and I'm, kind of chewing him up. One more part of this too. If he's upset about, voltage doesn't kill, amperage does, he needs to learn a little bit of lesson there, because guys, if you go into transmission, which, your career path is your own, you're going to be working live line 115, 230, 500,000 with your bare hands. That voltage will not kill you. The amperage will, once you make a path.
Yeah,
So that's true to fact. Okay, anything else? I'm done, Professor B.
I'm good. Any of you guys got any questions about anything before we move on?
For one thing, one question, who's going to buy a new tool?
Yeah, that's coming out of your pocket.
Yeah, you are.
Yeah. Okay.
Okay.
Unshare.
You can go ahead and unshare there. All right, gentlemen, this morning we're going to talk about protective devices, system protection as far as the industry is concerned. You know some of these already because we've gone through these as far as the substation is concerned. One's the ACI and one's the circuit breaker, but we're going to do those and include further protection devices that are out there on the line, all the way down to what's at your house. So let's do some definitions here. And I'm going to share a screen. Let me know when you got it.
That's it.
Okay. All right, so. All right, we all know what the ACI's purpose is for. Is that correct? What is the ACI as far as a substation is concerned? What's it protecting? First, what does ACI stand for?
Automatic circuit interrupter.
Thank you very much. Automatic circuit interrupter. And you know how the industry works here. Just follow the wording. Does it work automatically? Does it need a human there to do it? No, it's automatic. What does it interrupt?
It controls everything up to the breaker, correct?
Okay, you got the zone right there going on. You've got the zone area. All right, and it's meant to interrupt an entire circuit. Now, when they say interrupt, and if you see my mouse, it's hovering right up here. In some cases, in most cases, it's going to have to interrupt a high amount of current at one time. All right, this is the physical connection right here that goes all the way through the interrupter tube. So you're going to have a wire coming out of the back, and you're going to have a conductor coming out of the front right here. SF6 is the normal means of load break inside this tube right here, but it's meant to not only interrupt normal load on a circuit, but also fault load on a circuit. And we know fault load can be extremely high. So zone area is from the ACI, and it's protecting all the way up to the circuit breaker and a substation. Now, I will let you know, companies like to multi-purpose things. So I'll say it again. Automatic circuit interrupter. Can I put this in line? Can I put this in a transmission line and use this as a protective device to do like a large stretch of line? Let's say from Pawleys Island to Myrtle Beach, I've got a transmission line. Can I put this in line and make it a protective device in just the line only?
Yeah.
Sure, sure. You can multi-purpose things as much as you want to, as long as it meets the engineer's specifications for what the need is. Okay, you'll see down here in the bottom, it's got an open closed indication. So you'll be able to see it in that manner to see if it's open or closed. All right, there's also a panel you can open. It's going to have a flag in it, open, closed. All right, do you trust these as a normal open point? Normal visual open point.
No.
Okay, you cannot trust these as a normal visual open point. As far as this switch is concerned, can it be open and these bars be closed?
Yeah.
Yes.
Yeah, okay, the opening happens in here. every single time. Even if you trip this open manually, you want to open it yourself or skate it to open itself, that's going to happen in this area. Then a motor is going to turn. You see the bar that connects all three together. These insulators are going to rotate and the bar is going to swing up. That's going to make your visual open point, right? But you can have an open in the tube right here and the bar still be closed. So don't trust what you see here. What do? Test and ground prior to starting work. Okay, so that's the first item in our steps of protective devices right there. Any questions? Automatic circuit interrupter. All right. The next, and we've discussed this in depth right here. What do I have a picture of? What do these look like?
Breakers.
What now?
Breakers.
Breakers, yeah, circuit breakers, okay? I got my regulators on the far side, so I'm on the bus side right here. This would have been a perfect picture for your presentation.
Yeah.
The next portion right here is a circuit breaker. Now I've got some information on some of these that you need to pay attention to. What is the purpose of the circuit breaker as far as what is it protecting? Is it protecting the bus side? Or is it protecting the line side and the feeder going out?
Line side and feeder.
Line side and the feeder.
The line side and the feeder, exactly right here. If we have a feeder or line side fault, we don't want that to reach the transformer. Okay? If it happens on our line side, which has more exposure out there in the world, we don't want it to go through the breaker and then to the transformer. That transformer costs us a lot of money. We want to be able to sectionalize that portion of line with a circuit breaker. How do I know by looking at this box that I can determine that it's a circuit breaker? What gives me the clue here?
The coils on the top.
All
are
the
the same
bushings are the
size.
same size.
Right, insulators on top are same size in, same size out. So I know same voltage in, same voltage out. Now, I don't think we have any on this quiz, do we, Professor V, coming up about time? We did that on the last one.
Right.
Yeah, we won't have any specifics on instantaneous or time, but you have to know which portion of the line it's protecting. So I've got ACI, the bus side, ACI protects that. My lines on the feeder going out are protected by a circuit breaker. Does everybody know, can anybody give me the definition of what I mean by feeder or main line? Any ideas? And we need to get that down in a definition right there.
Guess it'll be like the main line going into the breaker,
Going to the breaker or from the breaker?
from the breaker.
Right. It's main circuit. Let me get this so you can see it largely. You got that one?
Yep.
It's the main three-phase circuit from the breaker REA out to distribute. distribute. That's all right. So I'm coming from my substation. It's the main three-phase circuit from the breaker out to distribute. You know, that's why we call it distribution. Okay. There are some rules to it. Now, you saw the video yesterday of the two old men, right? Professor B, correct me if I'm wrong here.
Roll on.
Feeder is not, okay, specifically NOT fused,
Correct.
okay? The only protection that you have on your feeder out there in the world is the breaker itself. So I'm not going to go down a portion of feeder line, put a fuse in it, and then continue on with the feeder line.
Right.
Right? It's not fused. It's only protection. It's a breaker. Okay. Some other attributes to feeder is larger conductor. Why do we have larger conductor on feeder? Think of the properties of amperage and voltage,
I'm just feeding more.
right? And what do we need if it's feeding more?
More room.
How about more amps,
Amps.
right? I need a bigger pipe because my main feeder line is carrying more amps, correct?
Right.
Correct, okay. All right, all switches, now I'm gonna need to have to go ahead and if I need to sectionalize it, all switches are, I'll bring a picture up for you. Dead blade. And I think I spoke with somebody about this. I think it was you, Tariq. What's dead blade?
Dead blade. I don't think it was me.
Okay,
But if I had to think,
let's do this. All right, let's go for a utility go out. We'll look at some images right here. Okay, where's the one we had yesterday? We can use this one right here. Image, open image, new tab. Get like this. Wow, that is tiny.
Tiny.
Yeah, we'll make it big. Okay. Here's my vacuum, my interruption device. That's the jaws of the switch. This blade that comes right here is solid copper. So when I have any time that I'm using a solid copper type connection between one side of the switch or the other, that is dead blade. Okay. No fusing capabilities here. No protection right here at all. It's only used for switching purposes.
it's always copper.
Yeah.
Okay.
This between here and here is copper. Let me see if I can find you a better picture. That was that one. Oh, here's one we can use, even though it's in a substation. Open image and news tab. This is still a dead blade switch. Okay. Between this side of the bus and this side of the jumper here, no protection on the switch. All right. Although we can open and close it, no protection at all. So this is made out of complete copper, Tariq.
Mhm.
All of this through this area right here. Now, surprisingly, what is the best conductor that's out there in the world?
Aluminum.
Silver.
Silver,
Yeah.
okay? What you're gonna come here, and as far as this lug connection, right here, and right here in the jaws of the switch, and the blade itself, this one raises and lowers when it comes in. You're gonna silver plate it. Okay, so you're making a real good connection between these points, but the whole thing's not silver, just the connection points right here.
Okay.
All right, a little bit what we talked about yesterday, guys. What are these silver things sticking up in the air?
A switch.
The silver.
Whips.
Static whip.
There's your static whips. Remember, all switches have static whips. Okay, so that's a dead blade switch. And now, let me go back here. And I'm going to do this. I can make a regular cutout switch a dead blade switch. So we're going to put in dead blade cutout. See if we get lucky here. We didn't. U-T-I-L-I-T-Y. And we still did. I'll find one here in just a moment. Any names that you'd have for it, Professor B? We always call them dead blades.
Yeah, well, solid blade disconnects.
Okay. Oh, solid blade.
Solid blade.
Solid blade. There you go. Perfect, Professor V. Perfect.
Mhm.
Okay. Some of these come pre-built.
Yep.
Like this. This is actually an attachment that you can put on a cutout. So this has been modified on this switch here.
Yeah.
To include a dead blade in it. It's a normal switch that we use, but now we have a dead blade in it. And it's made of what? Solid copper, silver connections at the connections point. This is not line protection. Okay? If you have something solid in between the two, it is not line protection. We have to have a fuse or some other means to have line protection going on here. So that's the definition for dead blade. Okay, what time are we holding? 9:35?
9:35.
Let's go ahead and take a break for just a moment, guys. Let's say 9:45. Let's come back. And the purpose of feeder line. So now that we've got the substation, we've got the ACI to the breaker, and we've got the breaker out to our feeder line, we can install protective devices in our feeder. And then we're going to go into taps and what we do as far as taps are concerned. So while we're sitting on that, we know the definition of feeder. What's the definition of a tap? Any ideas there? So I got my main feeder line going out. Then I want to tap off of that and say go down other roads, other streets.
It just is like on a keg, basically. It just like sends it different, brings it out and puts it somewhere else.
You're correct in that, but a little bit more of the definition on it. I've got my main line feeder, and by the definition we have up here, no fusing. Okay, no protection as far as in the feeder. We haven't, to discuss the ones we were going to talk about later, and all switches are dead blade. When I go off a tap and say I've got my main feeder, it goes all the way down 501, and you've seen it out in the field, I'm tapping off the highway. I'm tapping off the feeder going across the highway, and I'm going to the car dealership across the highway. Why do I tap? What's the reason for tapping?
To connect to go somewhere else.
Yeah, well, all right, the feed is to feed street.
To feed multiple.
Go ahead, Santarella.
Is it to feed multiple, like if it's like you showed us behind that car dealership, is it to like feed multiple things like that?
All right, yeah, it is ESSE, businesses. I don't know if that's spelled right or not. All right, it's to feed streets, homes, or businesses. Tapping off of the feeder. All right. I'm going to put this in here because you've done your presentations before. The first presentation you did, almost always fused. Okay. Now I'm going to put in here some solid. Remember when we talked about taps in our presentation, the substation to meter one? You put a fuse tap in there. It went off the feeder and went down a street. Okay. Some of those were solid taps. Now, solid taps, obviously, we know if we're tapping off the feeder and we have a solid tap, and somewhere on that tap we have a fault, it's going to take out the entire feeder because we don't have a fuse on that tap anymore. All right. And that's a reason why we have taps and we use fused switches in those taps. Okay. If we have, say, a squirrel get on a fused tap that's going down a street and feeding one house, all right, we don't want it to be solid or wired directly to the feeder. We want a fuse in there because if we have a fault down there, it's going to isolate itself with a fuse. If it's solid, it's going to take out the entire feeder. So for one customer on a solid tap, we want that isolated, just one. All right, and it's not taking out thousands because we have a solid tap. Does that make sense? We want fused isolation. All right, so good definition for a tap. Feed streets or homes or businesses, tapping off the feeder, almost always fuse, some solid. And even in a good portion of cases, Professor V, you could chime in on this one as far as Duke is concerned. They're going back to the some of these old timey solid taps, and they're putting fuses in them. They're installing a switch and a fuse in there. What are they doing at Duke?
Yeah, same thing. I mean, I can think of a time when I started with the company and we had a big section of line where it kept locking out in the summer. And it turned out to be, one tap that was solid, wasn't fused, that was taking it out. So yeah, they're
Mhm.
going through and putting fuses on all the taps. It just makes it easier to determine, what you got out.
Right. Okay. So that's the definition of a tap. In the feeder, though, we can install protective devices. We've gone ACI, we've gone breaker to be able to help in isolation. Now, the reason why you're going to have devices in your feeder right there is to limit the amount of people that were without power or for switching purposes. So our next one that we're going to look at here, I don't know why this got so big, is what they call a recloser. So we're going to go R-E-C-L-O-S-E-R. All right. A recloser, while we're sitting on that word, what do you think a recloser does?
Recloses.
Exactly. 100% right there. Okay. It detects a fault. Beyond itself. All right. Opens and recloses. Does this sound like a circuit breaker?
Mm-hmm.
It's very close to what a circuit breaker does, but it doesn't have all that extra technology inside of it. All right, they're all typically going to be instantaneous opens. Instantaneous open, wait, then close. Instantaneous, if the fault remains, instantaneous wait, reclose. Okay, wait a little bit, instantaneous fault, open, and reclose. That's all it does. It doesn't do the I and the T. It just detects faults beyond itself. All right, and of course, programmable. So say I've got, we'll go back to this picture right here. Say on the line that's coming into the switch from this side right here. Remember I said it detects faults beyond itself, and there's a fault on this sectional line going beyond itself, further down, inbound here, outbound here. It detects a fault, it's going to open, reclose, open, reclose, open, reclose, if the fault remains. Now, of course, inside this box, I can program it. Well, if it opens 3 times, I don't want to reclose anymore. 3, 2, 5, 10, 1, whatever you want to program it to. It just does not have all the brains that a breaker does in a substation. So a good application of this right here, and I'll give you an example that Santee Cooper has in one of these, is there is a feeder line between Conway that goes all the way to Loris. How far do you guys think that is? You guys that live out there in the woods.
Mm-hmm.
Anybody got a good guesstimate from Conway to Loris?
What was the question again?
About
How
40
far?
miles, 30 miles.
Professor V, you think? I'm thinking 20, 15, 20 miles right there. They've got one feeder circuit going from Conway all the way over there. Well, obviously, there's going to be a lot of customer in that feeder circuit, and that is a long, long, long section of line. All right. If a fault occurs beyond the recloser that they have about halfway between Conway and Loris, all right, I want to sectionalize, or I want to take out of service one half of that line, and the other half of the line that's coming from the breaker, I want to keep on. So that's a good indication of what a recloser is used for. Detect a fault, all right, reclose a specified amount of times, whatever you program it for, and if the fault remains, open. Okay, open. So it's got a little bit of brains and technology in it, but not as much as a circuit breaker. Okay, so that was recloser. Any other questions or any other ideas right there, what you're thinking of? Detects a fault beyond itself, opens and recloses. Let's put right here, programmed amount of times, all right? used on long line, sections. It's a good definitions right there. Okay. All right. Next one on our list. What's that look like? What picture were we just on? What's this piece of equipment called?
Recloser.
Recloser.
Recloser, all right? Does that look pretty similar to it?
Just without a box around it.
Nope.
Yeah, just without a box around it. Some of them get big. Sometimes it is hard to distinguish from the ground. A recloser, and this switch is what they call a sectionalizer. So let me go ahead and get that in the list. Sectional, L-I-Z-E-R, sectionalizer. I have to admit, out there, and Professor B's probably seen plenty of these different things. Sometimes I'll have to get in a bucket truck and ride up there and look at the nameplate. Is this a sectionalizer or is this a recloser? Okay, because there are two different purposes for them. Professor V, you seen those in your experience?
Oh, yeah, a lot of times. That's new technology out there, the ones you're showing.
Right. Okay. So what does a sectionalizer do? Look at the word. Remember, it's still in our feeder circuit.
Opens and closes, it's just sections.
Go, Scott, how did you answer this one? It does what?
It opens and closes in sections.
All right, when your first definition came out on this one, you said a reclosure recloses, right? That was your first thing. What does a sectionalizer do? Sectionalizes. Okay.
It sectionalizes it where the problem is.
There you go. Exactly. Okay. It sectionalizes a portion of line. Here's the difference between reclosure and sectionalizer. Detects fault and opens. Period. What's the difference between sectionalizer and recloser?
It detects it and opens it right back up.
The
Which one?
recloser opens and closes.
One closes and the other one doesn't.
Exactly. The sectionalizer sits out here, it detects a fault, it opens and does nothing else. Okay, it doesn't reclose, it doesn't do anything. I see a fault beyond myself. So let's go back to the picture. We'll say for this one, this is my inbound conductor, and we'll talk, this is all bypass switches right here. I got my inbound, goes in the switch, I got my outbound, goes out of the switch. A fault occurs somewhere down this line, it's going to detect it, it's going to open, that is it. Period. Okay. I want only one shot open, and that's all I want it to do. All right. Typically, these are not, and I haven't seen very many installed in overhead like this situation. Typically, we installed these sectionalizers like this when we went from overhead to underground. And I'll tell you the reason why here in just a moment. I'll tell you the reason why right now. You really want to prefer a recloser on a section of overhead line. Now, emphasize overhead. Why? If I have a tree limb fall on this line and it falls away, do I want this to reclose? It fell on it, then it fell away. Do I want this to reclose and get my power back on?
Yes.
No.
Yeah. Yeah.
Yes, absolutely.
The fault cleared itself on its own. This reclosed. Everybody's copacetic and happy. They got their power back. On sectionalizers, this is not the case. Okay. Sectionalizer, something falls on the line, it detects fault, open, I'm over with. All right, I'm going to change the scenario here. I'm going from overhead, I'm going to use this sectionalizer switch, and then I'm going to go underground. Now, do you think I want a sectionalizer on underground lines And if I have a fault on underground lines, why am I going to use a sectionalizer there? That's preferred.
Because underground's harder to find where your problem is.
Well, let's take it in this. I can see where you're headed with that. Let's take it in this manner. If I have a fault on underground wire or in an underground transformer, is it permanent? Will it fix itself?
It depends on the situation. Wouldn't it matter like if it was
Oh,
like good?
It depends on what it is, because a tree limb's not gonna fall on an underground line.
Exactly, exactly. So no
Okay.
animal's gonna fall away, no tree limb's gonna fall away, even a lightning strike. My wire's underground. So let's take this for an instance. I've got overhead coming in, I've got underground coming out. A guy in a backhoe digs into my wire. Is that gonna fix itself?
no.
No, I want a sectionalizer there to open one time and not reclose. I've got a fault inside a pad mount transformer. Is that gonna fix itself?
Yes.
It is.
Just gonna open.
No.
Yeah, sectionalizer is going to open. It's going to isolate the whole line. I mean, the whole underground line, and leave the rest of the overhead line hot. Where I'm headed here, guys, is overhead has temporary faults. Tree limbs, birds, animals, whatever, that have the capability of falling away and clearing themselves. Underground faults are permanent. All right, they don't fix themselves. When you have underground wire, underground equipment, if there's a fault on it, it will not fix itself. It will not clear itself. That is a good application of a sectionalizer. All right, fault occurs one time, sectionalizer opens. That's why we use sectionalizers. Does that make sense to everybody?
Yes.
Makes sense to Professor V.
Yes, sir.
Okay, so let's go back to our definitions here. Defect detects faults and opens. Let's see, prevalent in transition from overhead to underground feeders. Anything you'd like to add there, Professor B, as far as the sectionalizer is concerned?
No, sir. That's
Okay.
good stuff.
Good deal. All right. ACI, breaker, reclosure, sectionalizer. Okay, so now we get to discuss the fun toys of the game.
There you go.
Okay. What you're looking at here is a cutout, and it's been retrofitted with what they call either a 1 count or a 2 count sectionalizer. Now, I'll let you speak a little bit on this because of your experience with these, Professor V.
Yes.
When you first got these, how did you like them?
When we first got them out, there was a big misunderstanding of how they operated. They were, put in the field and they were not opening like they were supposed to. They were put in some wrong places, and we didn't really like them to start with. But once engineers got involved with it and started figuring out the right way to, or the right places, I should say, to install them, I mean, they work great. So, I mean, out in the rural areas, they came in handy, and they weren't just, we didn't call them sectionalizers. They were called PMRs, the poor man's reclosures, but same thing, sectionalizers.
PMR. Okay.
PMR.
So I've got my notepad back up here. Okay. You said reclosure here, and we'll get into all the functions here in just a moment. Right. We got sectionalizer in this one that detects a fault and opens. We've got a 1 or 2 count sectionalizer, so it still does the same thing as far as sectionalizing, but we have the opportunity of counting 1 or 2 times here, and we'll get into the details here in just a moment. Okay, so it does in here. Let me get down to here. Inside, let's go back. I want to put this into clear. used at both overhead and underground. I'm going to put this in here, taps. Okay, so we're out of the feeder now. A feeder breaker, that's where we were. Tap, we included this right here just to give you the definition of a tap. Reclosers in the feeder. Sectionalizers in line with the feeder. Now we're moving on to taps and tapping off the feeder. Okay, used at both overhead and underground taps. Period. All right, so how does it work? And this, you guys are going to need to know this and spell this out in a future quiz. All right, so it's got to work in orchestra or in relation to, get this all word, it works in relation to the substation circuit breaker. Okay. So I'm going to go back to the picture here. Surprisingly enough here, gentlemen, inside this portion of black right here, there's a lot of technology going on. And I don't know how they fit it all in this one little space, but it does work. All right. The bar or the metal itself is not a fuse. This is a solid piece of metal all the way through. Okay. At the bottom, they have what they call an actuator. Okay, that fires and opens the switch. Okay, so it takes some kind of force and an actuator fires and opens the switch. It essentially does what we do when we break a fuse. It pushes the foot down on the bottom of the switch and this thing swings open with an actuator. All right, so how does it work in correspondence with the circuit breaker at the substation? All right, so I'm going to type these steps out. These are on video. It detects a fault. Downline. Okay. When the fault is detected, also at the circuit breaker, I get what kind of target, what kind of operation? We'll go on the same scenario of instantaneous in time that we talked about before. A fault occurs on my line. The 2-count sectionalizer detects a fault downline. All right, that fault also travels to the breaker. The breaker sees it. What's the first operation a breaker does?
Instantaneous.
All right, breaker, instantaneous. All right, when an instantaneous happens, who's answered that?
Tim.
Tim, when we have an instantaneous on a breaker, what does the breaker actually do mechanically? Does the breaker open and close?
It does, yes.
All right, open and close. All right, this is the reason why we have count in here. And we're going to use a 2-count sectionalizer for this example. Sectionalizer counts one loss of voltage. I'll tell you, there's a lot of technology that's sitting inside this little thing right here. So the sectionalizer, when the breaker instantaneous opened, the sectionalizer at its location counted one loss of voltage. All right. The purpose of the breaker was to do what? Close back. The 2-count sectionalizer again detects fault downline. All right. We're going to get into our second breaker operation. I always put detects, not detects. Fault downline. All right. what does the sectionalizer do now? I mean, what does the breaker do now? Breaker does what?
Timed.
Breaker does timed open. Does timed open. Okay. What is the sectionalizer now seeing? Sectionalizer
Counts 2.
counts 2 loss of voltage. Remember, our breaker has opened up, does a timed open, is counted the second loss of voltage. Actuator fires. Okay. As soon as the actuator fires on the switch, bam, it goes down just like that, hits the bottom of the switch, this swings open. So it's counted 2 and it's actuated. All right, what's the breaker going to do next? Oops. Remember, it's in its second operation. Breaker does what? Closes back. All right, there's no fault anymore because our actuator had fired, correct?
Mm-hmm.
All right. So really, in the real world, what we're looking at there is on a 2-count sectionalizer on a section of overhead or underground line is giving me 2 chances to clear the fault, and my breaker is set up for 3 operations. So I've given it 2 chances to clear on a fault, but the breaker will close back and hold because the actuator had fired, and I haven't gone to my 3rd operation because the breaker closes, no fault. A lot of data going on there, isn't it?
So realistically, this narrows down the field of hunting down where the fault is to just one small little section where the actuator fires and opens the switch.
Well, to be honest with you, even if you're looking for a fuse switch or an actuator fired 2-count or 1-count sectionalizer, you're still going to have to hunt it as far as patrol is concerned. Professor V?
Yes.
Yeah, you're still going to have to find the location. Now, obviously, you know, you're going to get customer call-ins. So that's going to throw you in the direction of where you need to go as far as the dispatcher is going to give you that information. Okay. Another thing, and let me get, just so I can show you a location here.
But what I'm saying is instead of hundreds of miles, now you got probably 10 or 20.
As far as to patrol?
Yeah.
Yes.
Yes, yes. All right. Let me go to this location. I'll show you where some are actually installed. That's for you, V.
Yeah.
It always is. That's a busy man. Why can I not zoom out? Here we go. It's kind of sad when the internet at your house is faster than the internet at college. Okay, so we are going to go down to close to my house.
But I think my mobile hotspot's faster than that.
Yeah. We're going to move over here to Ocean Lakes. Plus. So we're going to go to the overhead part. We're going to drag our little man. I think I'm pretty close here. Let's go drive down the highway a little bit. Anybody ever been around Ocean Lakes before?
Yes.
Okay. So I'll give you some data here. Ocean Lakes in the summertime, around the July 4th week, the population of Ocean Lakes is more than the city of Surfside. A lot of people down in that vicinity down there. Okay. Here's my main feeder circuit, and I have two, one on top, one circuit on top, one circuit on the bottom. Now, this is especially helpful during storms and whatnot. This conductor size is bigger than what we're using at the yard, a little bit bigger, but not as big as our feeder size. So I can carry a good amount of amperage on this one. If I've got any kind of fault that happens, and this is just one of the taps that goes into Ocean Lakes. If I've got any kind of fault in there, I want to give it either 1 count or 2 count capability of clearing itself, and then the actuator will fire and open up one of these switches. So back, I think it was Timothy, back to your question, pretty much I'm going to hear a good many outages in this area down here in Ocean Lakes. I know right where to drive to, and I'll see an open switch. All right, this is only about a mile from the substation. But as far as identification, these are really good to use as far as identification is concerned. All right, another property of, let's see if I get the right one here. Nope. Another property of the 2 count sectionalizer right here is will carry up to, and they're making some new ones, 300 amps. All right, a normal fuse and switch, the largest size fuse that I can put in a switch is a 125. That's the largest that'll fit in here. All right. As far as a 2 count sectionalizer, it will go up to 300. So it just goes back to merit and to tell you, a lot of amperage, a lot of customers in here one time, but I still need protection off of my main feeder line. That's a good opportunity to go ahead and use this right here. So I've got 2 reasons. It'll carry a high amperage load, plus it'll either give me a 1 or 2 count capability of clearing the fault. Okay. All right, what time are we sitting on? 10:24. Let's say 10:35. Let's take a break and we'll come back at 10:35. You guys take a little bit of a break there.
So is it common for?
Let's go ahead and commence this operation. I'm going to start a new share here. Oh, you don't have to leave. Okay. So we've been through feeder, ACI, breaker. We got the definition of a tap, recloser, sectionalizer, 1 or 2 count sectionalizer, and how it works. And the last protective device we're going to go into here is the fuse cutout. All right. So let's get some definitions going here. Fused, cutout. And then I'm going to go also down here, fuse switch. All right, Professor V, you with us? You got to unmute there, buddy.
I'm here.
All right, just for us in Santee Cooper, so we knew what we needed either to construct or build for the linemen on the crew or whatnot. We had what we called a fuse cutout and a fuse switch. And really that's on the need of what you need at the location that you're working at, okay? Professor V, if I say I needed a fuse cutout or a fuse switch, what's the difference between the two as far as Duke's definition?
Really, we didn't distinguish it too much. It was, in our terminology, we used it for the same thing. It was either transformer or tap line. So
okay,
those kinds of things.
It's just the way you use your verbiage, and I like you guys, you know, when you hear something, you hear an instruction to, you know, get something for a lineman or build something for them as far as its construction. A fuse cutout to us was no arrestor. Okay. All you were going to build here would be the L bracket all this stuff right here. You'd have to get a fuse for whatever they specify you need right here, and the cutout itself. So we know these pieces from what we discussed about before, both outside, when we're taking our cutouts or switches apart together. All right. For us, a switch, the only thing here is it has an arrestor. All right. So a fuse switch, all you got to do on the picture right here is add the lightning arrestor to it, and then you're good to go. Now, as far as a fuse cutout and a fuse switch, you're going to use these at different locations. For transformers and anything that you need to arrest lightning at, you want to keep that as close to the location as possible. So we want to protect the transformer from lightning. We're going to use a fused switch. It's going to have a lightning arrestor installed on it. As far as a tap line that goes across the highway, depending on what the engineer specifies, we're just going to use a fuse cutout only. All right. And it really goes to the point, well, if I have fused switches and arresters at all my transformer locations, I'm really not worried about the line. I can use a fuse cutout because I'm already protecting at the transformer. Does that make sense?
Kinda.
Lightning strikes the line. Let's put it in this way. If lightning strikes my tap line and I don't have lightning arresters at my transformer locations, they're going to get damaged from the lightning strike. Okay. Then I would put a lightning arrestor at my fuse tap location. But for protection and to be better capable of protecting my transformer, I'm going to put a lightning arrestor on my switch at every transformer location, just like we do at the field. Since I have done that at every transformer location on my tap line, I don't need to protect the tap line anymore. I don't need an arrestor at this. So it's kind of a back and forth type thing. Really, watch what the engineer specifies on the work request or what the lineman asks for. He says, I need a switch. Get him a fuse cutout with an arrestor on it. He says, I need just the fuse cutout. You don't need to put the arrestor on it. Okay, it's going to be specific to each job that you work on. All right, so what, as far as fuse cutout and fused switch, both of them, what is their purpose? Obviously, by the word here, fused, what are they intended to do if there is a fault detected beyond the fuse?
Blow the fuse.
All right, blow fuse. There's very little technology going on here, if none at all, as far as the fuse is concerned in the switch. It does have to coordinate with all the rest of the equipment, but all it's supposed to do is blow the fuse. All right, I'm going to put over here, fault occurs, blow the fuse. Same on this one, fault occurs, blow the fuse on the fuse switch or the fuse cutout. All right. Any questions there on both of those? Okay, what time are we holding? We can get into this. Oh, okay. All right. So how do I know in looking at a fuse, say the switch is opened up? Not that one. That one. The barrel's hanging down. There's a simple process right here you guys can take and when you inspect a fuse to tell what kind of condition or what made the switch open up. We all know the difference between overload and fault, correct? Let's see this. I'm going to pick on somebody. Let's see. Cameron Rogers, just because you're on my screen. Cameron.
Yes, sir.
What's the difference between an overload and a fault?
An overload is too much, and a fault is something went wrong, basically. Does that
Oh,
make sense?
something's going wrong in both, okay?
Yeah.
All right, remember in overload, say I've got a 10 amp fuse, it's just gone a little bit over the 10 amp capabilities. Really, it'd go to 150%. So that's 15 amp. It's going to 17, 18, 19, 20. That's overload.
Mhm.
All right, what's the difference between that and a fault?
Hold on. Fault's like a cutout, ain't it?
Well, what is a fault itself? Very intense,
Trying to get those.
all right?
Yeah.
Very high amps. Okay? When this occurs, either the overload or the fault, the switch is going to open. You can take the fuse out of the fuse barrel. We've done this out in the field where we replace the fuse. And a melted, what we call a melted fuse, is an overload. You take the fuse out of the tube, and you can still see the connections of the fuse inside that have melted away. All right? In a fault condition, the fuse will be destroyed. All you'll have is a little piece of wire rope, and the rest of what's inside the tube will pretty much be gone. So that's a good indicator right there, is when you take that cap off the end of the fuse barrel and you take the fuse out, if most of the fuse is still there and you see the melted tips of the connection come out with the wire rope, that fuse has been melted. You just had an overload. If you start taking the wire rope out of the fuse barrel and then take the cap off and take the other end off, there's nothing left. It's just burned up. So that's a good detection method of finding out if you've either had an overload or a fault when you come to an open switch. Okay, Professor V, do you have the quiz up? Because I don't want to share my screen here. You're muted.
Okay.
Okay.
Got it.
We had two questions on lightning arrestor, correct?
Oh, melted fuse over high ampage and faults lightning. Yes.
Okay.
3.
So go ahead and read me off the first one.
Okay. All right. You got a picture of lightning arresters.
Uh-huh.
A lightning arrestor stops the flow of overvoltage, blows the fuse in a switch, redirects overvoltage to the line or transformer, redirects overvoltage to the ground.
Okay. We've discussed this, and I know it's been a good while back. Lightning arrestor, in my terminology, when they say arrestor, to me, and you know, I think logically right here, is lightning is going to strike something, it's going to come to a point, and it's going to be stopped. Now, from what you remember before, is that the case really when we have a lightning arrestor installed? Lightning strikes, you guys that have done and taken the switch apart and down and back up, you'll notice the high side riser comes into the front of the arrestor. What's on the back of the lightning arrestor? Where does that connect to?
The fuse?
The back of the lightning arrestor. Hold on one second.
Next to the pole, right?
Goes to the pole ground, correct. So a lightning arrestor truly does not arrest.
Was it a lightning ground?
It redirects. Okay. If I have over voltage, goes to ground. Okay. So if I have a line that's 7,200 volts, I'm going to have a arrestor that's typically rated to 8,100 volts. Once it reaches that rating of 8,100 because of the lightning strike or more than 8,100, it's going to go and take that lightning strike to ground. It won't proceed into the transformer. So lightning arresters redirects over voltage, and that goes to ground. Okay. All right, so we are sitting at 10:49. Let me look at, so I'm gonna stop my share real quick, see how much deeper we want to go. There will not be a quiz today. This quiz will more than likely happen tomorrow, depending on weather. Weather's not, it's drizzling rain here and cold. Check something real quick. Confirm resolution, continue. Quizzes. And take a look at this protective equipment. All right, and if you really think logically here, you know, we've talked of all the protective equipment down to a fuse. A lightning arrestor is also a piece of protective equipment. This thing takes forever. All right, just to talk about a lightning arrestor a little bit more, it can sustain multiple strikes. So it's not like lightning is going to occur. It's going to take that to ground and just be done and over with. You have to replace it. Multiple strikes could happen on that line, and that arrestor is still supposed to do its job for a certain amount of strikes. Now, that's not to say that you can have a real intense strike and it blows the arrestor up. It needs to be replaced, but arresters are meant to be out there on the field and sustain multiple strikes. Okay. Go ahead and put this down. Okay. Professor V, I think that's as far as I'll take it today.
Roger.
Okay. Any questions about anything we have discussed today? Of course, this will be on video. And my expectations are, if the weather does not clear up tomorrow, we'll be back in Zoom, and hopefully we'll have Thursday on the field. All right, so guess what? When was our meeting for the CDL?
Thursday.
All right, it's been moved to today.
What?
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 Yeah, what?
Who?
So 3 p.m. here at the college. I'll bring up a map for you. Let's start a share. Share this. Get your map of the college. HETC, Conway map, campus map. I think we can do this.